That's what I thought.
Okay, so this is pretty short. I'd like to get through this. It's a kind of a short little, get intense, get through this thing real quick, and you get a chance to get some work done, get questions answered. There's an assignment for this. Some people have already got it done. It wasn't very long, was it?
It's 15 questions.
But I think a lot of them are pretty short.
Yeah.
Okay, so let's look at this here. Infinite limits. As you might expect, infinite limits are limits that give us infinite answers, right? So what about the limit of 3 over 1 minus x as x approaches 1? If I try to directly evaluate that, what do I get? 3 over 0, right? So that's a does not exist answer. But we can maybe be more specific with that. To know if we can write something more than does not exist, we have to check the one-sided limits that build that two-sided limit. Okay, so let's try both of the one-sided limits. What if we take the limit of 3 over 1 minus x as x approaches 1 from the right? Okay, now here's where we want to see if we can come up with a way of dealing with this. As x approaches 1 from the right, if we try to evaluate this directly, I got a 3 on the top. What do I get on the bottom?
You get infinitely close to 0.
Okay, it's going to be,
Yeah.
but it's positive, isn't it?
Yes.
Right? So I'm going to call that a 0 plus, because 1 minus a number slightly bigger than 1 would be a number that's, hold it, are we sure about that?
Yeah.
1 minus a number slightly bigger than 1. Because 1 plus is like 1
it's gonna be
point
0
something,
negative.
right?
Yeah.
So 1 minus 1 point something,
Yeah.
isn't that going to give us negative point something?
Yes.
Right? So that's actually a 0 minus on the bottom, isn't it?
Yeah.
Okay. So now how do we interpret that? I alluded to this yesterday. We did kind of an introductory example. But how do we interpret that result? First of all, let's focus on just the 3 over 0 part means what? Well, okay, but when we say does not exist, that's telling us something specific. Okay, it means it's exploding vertically, right? If we divide a number by 0, it means it's getting infinitely big. So that part right there is telling us this is infinite, but we got to know there's a big difference between positive infinity and negative infinity, right? And asymptotically, what would that look like? If we're approaching 1, and there's our asymptote. As we approach from the right, there's a big difference between the ant going up forever and going down forever, right? Very big difference. So we got to know which one. Well, to know which one, we're going to analyze the signs of all the factors. There's only one factor on top and one on the bottom in this case. I get a positive divided by a negative. What's our sign, Ralph? Negative. So from the right, this function is doing that. As the ant approaches from the right, it's plunging to negative infinity. Okay? What about the bottom case? If we evaluate that directly, I'm going to get 3 over what? What's 1 minus, 1 minus. That's kind of awkward to say, but 1 minus really means something like 0.99999, right? Something slightly less than 1.
0 plus 0.
Good, that's giving me a 0 plus, isn't it? So I interpret that as it's infinite, but then we know it's positive because I get positive divided by positive. I don't write the positive sign there. Infinity implies positive infinity, right? And so from the left, if I approach 1 from the left, I see that going on, right? And so that tells us the behavior of the function. So then if we go back and look at the two-sided limit, can I say something specific about it? I can't. I can't say anything here specific because the limits from either side were different, right? Now, what if they had both agreed that they both were approaching positive infinity? Well, then I could have said infinity there, right?
Mm-hmm.
Okay. Let's try another one. What about this? Trick, isn't it? This isn't hard. What's the answer? 0. Yeah, I get 0 over something that's non-zero, 0 over some number. The bottom's not 0, so I don't even care what it is. 0 divided by a number is what? Yeah. Right? Question?
Wouldn't it be 0 positive, 0 plus?
But do we care? Right? Do we care? So what if it's, what do I care what the sign of 0 is? It's approaching 0. See, that's different in this case. In this case, the signs were important because I'm approaching two infinitely different locations. But here, who cares? Who cares if the limit is 0 plus or 0 minus? I'm approaching 0 arbitrarily close, arbitrarily closely. Does that make sense?
Yeah, I was just saying on the numerator, would it be
It-
0?
It would.
Okay.
It would, but in this case, that's irrelevant, right? We don't really need it. That's only relevant information if we're dividing by some number by 0. And we gotta know which species of infinity is that, positive or negative. Otherwise, we don't care, right? We've done a ton of limits prior to this, and we've never, ever needed to know what the sign of the 0 was. We don't care. We're just approaching 0, right? It's the fact that we're approaching from the right, what difference does it make? It's gonna be the same thing from the left, isn't it? Or we just get an answer, that's clearly, we're gonna get an answer to that two-sided limit, that's 0, regardless of which direction we approach from. Okay? Questions? That make sense? Okay? Okay, next one. Let's click those things close too. This will be brief, and I know you guys wanna get going on homework, and I'll let you, but I wanna get your undivided attention. This is good stuff, seriously. This kind of thing, this is where you really learn math, is just having these conversations. How about this one?
0.
Okay, this one's, yeah, so we get 0 over 0, right? This is a little tougher though, isn't it, to ascertain, the bottom is 0, what? What flavor of 0?
0.
Okay, 0 plus, good. But what about the top? I mean, you know, and is it important? We do get 0 on the top, don't we? So if we get 0 over 0, that means more work anyway, doesn't it?
Yeah.
Right? So we don't really need to know if it's 0 plus or 0 minus. What do we do if there's more work? What's that mean? Yeah, we got a factor. We got to somehow cancel factors there, don't we, in this case? So we're going to get the limit as x approaches 5 from the right of x minus 5. What am I going to get on the top?
3
Just factor out of 3.
X plus 5, x minus 7.
And then I'd end up with x squared minus 25, which is a difference of squares. Good. And so that's equal to, I could algebraically cancel this, couldn't I? Right? So that's equal to the limit of 3 times x plus 5 as x approaches 5 from the right. Well, what do I care if it's from the right? What's my answer? 30. Right? If I just evaluate correctly. Okay, what about these? So what am I getting on the bottom?
0 positive.
I'm getting 0 positive squared, right?
Yeah.
Okay. Okay. Well, what's 0 positive squared?
0 is positive.
Yeah, 0 positive is a small positive number. What about the top? There's the limit at the top. It's hard to tell, isn't it? If I'm plugging in 4 plus, I mean, we can evaluate that thing, it's fine, I guess we can do that. But is there anything we could do to the top here that might make things easier? Yeah, let's factor it. What if we factor it? So if we factor the top, we get x minus 5, x plus 2. Did we absolutely have to do that?
X
Probably not.
minus 2.
What did I do?
X minus 2.
Oh, minus 2. Okay, good. That's better. So did we absolutely have to do that? No, we didn't, but it makes things easier. Here's why it makes things easier, because if I can get the top factored, it's much easier for us to determine what the sign is, right?
Yeah.
When x approaches 4 from the right, what signs am I getting? Well, the bottom is positive. What's going to be the sign of that factor?
Negative.
It's, yeah, and it's, what do I get? X pushes
Negative
forward to the right. I
one.
get -1, and then here I get +2, okay? So I don't really care what I get on top. It's not 0 though, is it? Right. What I know is that I'm going to end up getting some negative number on the top, and it is -2. Now we know what's going on, right? I have a negative numerator and a positive denominator, and so what's the result? Negative infinity. Okay, same thing here, right? The work's going to look very much the same on the top. If we factor that, we get x minus 5, x minus 2. What do I get on the bottom if I evaluate this at 4 minus?
0 negative.
I get 0 negative squared. What's 0 negative squared?
0 positive.
0 positive, right? Small negative number squared is a small positive number, right? So we end up with same as before, isn't it? If I evaluate this at 4, I get negative infinity. So this time, what is the answer to our two-sided limit? Negative infinity, because I got the same behavior from both sides of the function, right? Both sides of 4. Okay? And so we know this one, if I were to graph it, sketch it. The function's doing this, isn't it? It's going down on both sides. Okay? All right. How about that? So when you try to deal with composite trig functions, you know, the ones that are built from the fundamental, from sine and cosine, it's always more difficult to think of them by themselves, I think. What should you probably do first here? Change it. You could do 1 over tangent. Okay. Maybe even better than that. Yeah. What is that in terms of cosines and sines? Cosine over sine. Isn't that better? Because we know, you know, it's, you gotta really scratch your head to think what cotangent and tangent and secant and cosecant do, right? But sine and cosine we know very well. So we could write this as the limit of cosine x over sine x as x approaches pi from the right. Now this is a little bit tricky. So I'm going to show you a couple different ways you could think about this. So you could think about it in terms of the graph, but as x approaches pi from the right, we got to be able to evaluate the top and the bottom. Well, what's the cosine of pi? Okay, now, I'm a big unit circle guy. Unit circle is, the unit circle, and I know everybody kind of dreads that, but if you know the unit circle relatively well, it tells you everything you need to know in trig. I mean, throughout the year I'll show you some tricks where you can use it for just a ton of stuff, right? A ton of stuff. So on the unit circle, where's pi?
Left side.
Left side. So there's pi. Okay. Now we know that the coordinates on the unit circle are always going to be, if that's theta, it's it's alphabetical. C before S, X before Y, right? So the cosine of the angle always corresponds to the X coordinate. Sine corresponds to the Y coordinate. So the coordinates here are -1, 0, right?
Yeah.
So we're going to get -1. Now what about the bottom?
0.
Okay, 0, but what kind of 0? 0 plus? Okay, let's see. There's a couple ways we can look. Let's look at a sine function. Sine function starts at 0, right? It just goes like that, right? Okay. So where is pi in a sine function?
In the middle.
Oh, okay, right there. Right there's pi. So if I'm approaching this point on a sine function from values of x greater than pi, that ant is walking along the function from this direction, isn't he?
Yeah.
So he's approaching 0.
So it's from 0 to
Yeah, but he's approaching a y value of 0 from negative y values, isn't he?
Yeah.
Everybody agree?
Yeah.
So that's a 0 minus. Here's another way to look at it. I think this is better. Think in terms of the unit circle, right? So if this is pi right there, this is going to be, in which direction, when we sweep out area on the unit circle, we sweep out area in the positive direction, which is counterclockwise, right? So this is 0, that's pi halves, that's pi, that's 3 halves pi, right? So where on the unit circle would I have to go to be at something I might call pi plus? Down, don't I? Pi plus is a little bit bigger angle than pi, and so that's pushing us very slightly into quadrant 3. Okay, in quadrant 3, so if I'm down here, I made my y-coordinate negative, didn't I? Either way you slice it, that's a negative on the bottom. Okay? And the trig functions are just tricky that way, right? Because the trig functions oscillate. Okay? They can have different signs in different places. Now it's easy. What's the answer? Positive infinity. It's infinite because I've got a number divided by 0, and the sign rule tells me positive. Okay? So the limit of cotangent x as x approaches pi from the right is positive infinity. And we can see that if we plug that function into Desmos. And this is kind of cool in Desmos. I'll show you something. Maybe I already showed this to you. I probably did. So there's cotangent x. If you go up here to the menu, did I show you this?
Yes.
Okay,
Because
yeah.
I did that.
Yeah, this is kind of nice. So if you go negative
Steps.
2 times pi to positive 2 times pi in steps of, let's say, pi divided by 2. That's a pretty handy way to do it, right? And where are we? Well, I would be approaching pi from values, what did we say, greater than?
Yeah.
From values greater, oh, hold on, what the heck? Is that what we got before?
And
Oh, it was, that's right, yeah, that's right. Yeah, so if we're approaching from values slightly bigger than pi, I was thinking we got negatives. What was wrong? You can see that the y values are just going to increase forever, aren't they? Right? Okay? All right. I think that's it for today. You can work. You might have questions, but that's all right. You got time.